Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 35, the last one in chapter 5. We're going to be proving quadrilateral properties. In other words, we're doing more proofs today. So let's go over some ways to work proofs. It's often easier to work backwards. Most proofs we've done so far have been set up for you, and you're providing reasons. It can be difficult to create the entire proof on your own. One hint I have is to work backwards. Start with what you want to prove and then find the reasons to prove each step as you go. So you're going to start with the last one. How do I prove that these triangles are congruent? Well, I need one of these. I need AAA, or I need SAS, or I need ASA. And then which one of those could you use? So that's how we'll look at some proofs. If you've ever tried solving a maze backwards, you'll know that it's often easier. So we have this picture of a fireman. The guy over there with the hose is asking the one with the wrench to turn on the hydrant. And the one with the wrench is saying, which one? Well, a high pressure hose without someone holding onto it could cause disaster. So work backwards and see which hydrant the fireman should turn on. So we'll start with the hose here and see where it goes. This one's a little hard because you have to go under the layers, but I think we can figure it out. These are some tangled hoses, aren't they? It appears that it's the second hydrant. So had we started at the hydrants and traced, we would have had to go at least once or twice, unless you were good, and 2 or 3 times, unless you were good and picked the second one to start with. So working backwards means we only had to trace one hose. So when we're doing proofs, try drawing on the diagram what you know, and then look at what you want to try to figure out and work backward to prove each step aloud. Then turn your thinking into a flowchart, or if you want, a 2-column proof or a paragraph proof. The exact writing and method that you use is not really as important as detailing every step and reason so that you're making connections to each new statement. When working the proofs in your textbook, feel free to use whatever method, a flowchart, a 2-column proof, or a paragraph that works best for you. Let's look at this dart. So a concave kite, which is what this is sometimes called a dart. We will work with this dart for the proof. I'm going to look at what is given. It says that it's a dart. It says that AC is congruent to BC. So that's this line here is congruent to this line here. It also says that AD is congruent to BD. And that would be our definition of kites, right? The two lines next to each other are congruent to each other. Now, they're trying to ask us, what if CD bisects ACB? So we might think, if CD is the bisector, then we would need to prove that angle ACD is congruent to BCD. Because right before we say it's a bisector, we would need to prove that the angles on either side of it are congruent. So how could we prove those angles congruent? Well, if I look at it, I think, well, maybe if I use these triangles on the inside, so this triangle here and this triangle here, if I use the triangles, then I could use our corresponding angles to prove that those angles are congruent. So how could I prove the triangle's congruent? So remember, with triangles, we have side, side, side. We have side, angle, we have angle, side, angle, or we have angle, angle, side. So those are the ways that we could prove the triangles are congruent. Do we know anything about any of the angles? Because 3 of them use angles and sides, and we already know 2 sides. Can we prove any of the angles congruent? I don't think so. There's no vertical angles. There's no parallel lines where we could have a transversal. So I think we want to try to look at side, side, side. We have two sides already. Could we prove that CD is congruent to CD? I think so. So we're going to be using this proof for the triangles, and then we could get to this because they're corresponding parts, and then we could prove that they bisect. So we really only need to prove that CD is congruent to CD. So I'm just going to mark it here, and we know that because that's the reflexive property. It's the same line. So I'm going to put my, right here, my triangle congruency. So ACD is going to be congruent to triangle BCD. And I know that from side, side, side. So now that I have that, I'm going to find my three sides and list those. So how did I prove that my three sides were congruent? Well, this one was the one that I said CD is congruent to CD. And I know that from the reflexive property. It's the same line. Now, what are the other ones that I used? Well, they were given to me right here. So AC is congruent to BC, and that was given. And AD was congruent to BD, and that was given. All right, so the three of these flow into the triangle congruency because that's side, side, side. I need to prove the three sides. From this, I can go straight to my angles that are congruent. And they are congruent because they're corresponding parts of congruent triangles, so they're congruent. And then I can mark it on my drawing here. So I might mark that this angle is congruent to this angle. And once I have those congruent, I can say that CD bisects ACB. And that is because that's the definition of an angle bisector, is that you would have congruent angles. Now, how would that look in a two-column proof? Well, in a two-column proof, you're just listing these in order. So this might be 1 and 2. In a two-column proof, I'm always listing my givens first. You could list them before you need them, but if they're all at the top, then you can use them whenever you need to. I might make this step 4, 5, and 6. So what does that look like in a two-column proof? Let me show you. So I have my statements, and then I have my reasons. Now these are the type of proofs that I grew up doing, not those flowchart proofs. So I like this one better. But again, you just use whichever method works for you. So AC is congruent to BC, and sometimes in a two-column proof, you could even say, and AD is congruent to BD, because your reason is the same for both of them. It was given. Now, the next thing that we said was that CD is congruent to CD because it's the same line. It's, oops, number 2 is the reflexive property. And then once I had 3 sides that were congruent, I could say that the triangles were congruent. ACD is congruent to BCD, and that's because I proved 3 sides, so it was side, side, side. Then I could prove my angles. Angle ACD was congruent to angle BCD, and that's because those are corresponding parts of congruent triangles. And then my last one would be, my last one is always what I was trying to prove. So CD bisects ACB, and the reason behind that is that once I know that the angles are congruent, that's my definition of an angle bisector. is that it bisects the angles and it makes two congruent angles. So if I prove that the angles are congruent, then I can say that that must be an angle bisector. If you wanted to write it as a paragraph, you might say, it is given that AC is congruent to BC and that AD is congruent to BD. And so that's your first one. You say it's given that these are congruent, and then you could say CD is congruent to CD because it's the same segment in both triangles, or the reflexive property. And then you could say, I know that triangle ACD is congruent to triangle BCD because of the side-side-side congruence conjecture. So you're just writing these in sentences instead of making a chart. After that sentence, you might say, so angle ACD is congruent to angle BCD by the definition of congruent triangles, or corresponding parts of congruent triangles. And then you could say, lastly, by the definition of angle bisectors, segment CD is the bisector of angle ACB. So again, a paragraph proof would just be writing them in sentences instead of making a chart or drawing a flow diagram. Okay, here's another one. We see this quadrilateral with two triangles in it, and it says it is given that angle B is congruent to angle D. So I want to mark my givens right away. And BC is parallel, so you're going to mark that with like a colored in triangle. BC is parallel to DA. Prove that ABC is congruent to CDA. So we're trying to prove these triangles on the inside. Well, right now, we know that we need 3 parts to prove triangles, and we only have 1 part. We only have 1 angle that we have been given that's congruent. But we were also given parallel lines. So what could the parallel lines help us prove? I like to extend my parallel lines so that I see those parallel lines, and AC is running through it. So I'm going to say that might be a transversal. If I see that as a transversal, then what angles could I prove are congruent? DAC right here would be congruent with ACB because those are alternate interior angles, interior of the parallel lines and alternate of the transversal. So then I have 2 angles, and I need either, well, with 2 angles, I have to have a side, right? 3 angles wouldn't prove my congruency, so I need a side. I could have the side in between, or I could have either of the sides next to it. Well, do we know that AD and BC are congruent? Not necessarily. This wasn't a parallelogram, it was just given that the outside lines were parallel. But this AC is the same as CA. So I think by reflexive property, we could prove that that is congruent. So then I have 2 angles and a side. So how do I write that? If I was doing my 2-column proof, I would write my givens, and I could even write them together because the reason is the same, that they were given. I then used this parallel lines to say that DAC was congruent to BCA, right? BCA. So DAC and BCA were congruent. Those angles were congruent because of what? Well, those parallel lines with AC as a transversal, and these were alternate interior angles. And then I needed one more piece to make the puzzle, and I said that AC was congruent to CA. Now, why in one proof did I say AC, or did I list them the same order? That last one, what was it? I said that CD was congruent to CD, and this time I'm saying AC is congruent to CA. Well, it's not a big deal. I'm listing them that way because when I prove my triangles, it's going to be it's going to be segment AC is congruent to segment CA. One of them is going to go this way and one of them is going to go this way. So that's why I listed it that way. It would not be a big deal if you said AC is congruent to AC. You could say it's the same segment, or you could say reflexive property, because that's what reflexive property is about, is it you have the same segment or the same angle. Okay, so now I have this one, this first one up here gave me an angle, this one gave me an angle, and this one gave me a side. So I can prove that the triangles are congruent because of angle, angle, side. Now, if I were to write this in a flowchart proof, I would need these to be separate pieces. So we'll call this 1A and 1B. So in a flowchart proof, I'd actually probably do 1B out here and then let that flow to number 2, which is that my angles are alternate interior angles. And then I would have my 1A up here, my angle part right here. And then I would have number 3 here. And I list them on top of each other because then I can draw all of them together for my final picture, which would be the angle, angle, side. So this was one of my angles, this was my other angle, this was my side. And I would do them that way so that you see that they all flow into that triangle. This would have been given, this one was also given, this was my alternate interior angles, and this was from my reflexive property. All right, last practice for today. We want to write a proof to demonstrate that this quadrilateral, SOAP, is a parallelogram. We are given that SP is parallel to OA, so that's what these little triangles mean. And we are given that SP is congruent to OA. How are we going to prove that it's a parallelogram? Well, starting with the end, to prove it's a parallelogram, we would need to prove that the other sides are parallel. So we would need to prove that PA is parallel to SO. So how are we going to prove that? Let's think of some ways that we have worked with parallel lines before. Sometimes if we prove that angles are congruent, we could go backwards from our maybe alternate interior angles or alternate exterior angles. So let's kind of draw this out and see what we think. So if this is parallel to this one, then let's see, this line could be a transversal. If I knew that 3 was congruent to 4, then I could say that alternate interior angles converse would prove that those lines are parallel. Okay, so that might be our second to last step. Angle 3 and 4 are congruent. Now, how could we prove that angles 3 and 4 are congruent? I don't know. Let me draw with a different color and see if we're looking at these parallel lines and this one as our transversal, what would we know? We would know that 1 and 2 are congruent because those are alternate interior angles when I'm looking at these blue parallel lines. Could I then prove my triangles are congruent? I have a side and I have an angle. Could I use the other side right here? I think so. All right, so let's see if we can put this in order now. All right, SP is parallel to OA, and that is given. And because that's parallel, then I can say that angle 1 is congruent to angle 2, and that's because they are alternate interior angles. All right, so I have one piece of the puzzle, that would be an angle. Then I'm going to need something else. I have one more given, that SP is congruent to OA, and that was given. Okay, so this is an angle, and that's a side, and then I said I had another side. And because the angle is in between, it's side angle side, so we can use it. So let's use my other side, and that would be PO congruent to OP. I think they're going to be used in the opposite direction, and that's reflexive. It's the same one. All right, so there's my other side. So these all come together, and they prove the triangle's congruent from side angle side. Let's see if I can list my triangles correctly. If I start with SPO, then I need to start with the same corresponding part. So that would be A, and then OP. So those triangles are congruent. Once I prove the triangles are congruent, I can go back to what I wanted, which was proving the parallel lines. I would need to prove angles 3 and 4. So angles 3 and angle 4 are congruent because they're corresponding parts of congruent triangles. And then once I prove those are congruent, I could say that PA is parallel to SO. That was what I was working on here. And that's because it's the converse of alternate interior angles. And then the last thing would be that SOAP is a parallelogram, because the definition of parallelograms is that opposite sides are parallel. You could even put that if you need to. Opposite sides are parallel. So this one was a little harder, but we worked through it. We thought about what we needed to prove. We thought about how we could prove that. Going backwards, saying, well, how do I prove parallel sides? Maybe with alternate interior angles converse. So when I originally thought of this one, I wanted to say, oh, well, if I do those triangles, then I could prove that, opposite angles are congruent and opposite sides are congruent. And that would be, that's a parallelogram. We just did some lessons on what are some properties of special parallelograms. But we didn't have converses of those. So when I went back and looked, I said that in a parallelogram, the opposite sides would be congruent. But I did not say because the opposite sides are congruent, that's a parallelogram. And so I couldn't use opposite side congruent to prove a parallelogram because I didn't use it in the converse. I didn't have a converse. I haven't proved a converse. So make sure that it is things that have been proven that you're using. This is also the end of chapter 5. So after this lesson, make sure that you check your understanding, that you've taken a test, and that you are ready to move on to chapter 6.